I'm Carmela Carpentieri from Istituto Superiore di Sanità, and my co-chair is my colleague Andrea Majorana from the same institute. We are welcoming all of you to this session, and we start with our first speaker. I give the floor to Andrea.
Thank you, Carmen. We will continue the session on recommendations of the, now we are in block 3, about norm. We have 3 speakers with high expertise and long experience in the field of norm. And let me introduce the first one, that is Jelena Popic from, she's a senior advisor of the Norwegian Radiation and Nuclear Safety Authority. And so I give the floor to her for her presentation. Thank you, Jelena.
Thank you all. Good morning, late morning, almost afternoon to all there. And first, I really need to apologize for not being there with you as planned. But anyway, I will now share the screen and try to give a presentation in a due time. And this is a presentation you already. Yes, it works.
I just want to remind you that you have 25 minutes and then 5 minutes for the question at the end.
To be honest,
okay.
Yeah. Yes, you just finished, or I put the ring on my phone to remind me not to use.
Thank you very much, because we are a little bit late on the schedule. So thank you.
It can be, yes. Well, this presentation, yes, I am Jelena Mrdaković-Popić. The first last name is difficult a bit to pronounce, but from Norwegian Authority for Radiation and Protection and Nuclear Safety. And today I will present a presentation on methodologies and tools and survey, all that was developed and done in previous years in radionorm for mapping and characterizing norm exposure situations. And this is a joint presentation by myself and colleague Bogusław Michalik from Polish Mining Institute, but he will later on has another presentation, so this one I will present. And also, of course, this is on behalf of all Task 2.5 participants that really contributed a lot to the work that will be presented by me today. So very shortly outline, I will just in few sentences give a background for the work, and then I will go on methodology, how to identify norm exposure situations and that can be maybe of radiological protection concern. Then we will go on tools that were developed, how to collect relevant information when we have these sites identified, and then also some results from norm survey that was conducted in 2022 to get supplementary information on the norm from countries, European countries that are non-participants in this radionorm project. So to have some overview picture on the norm in the whole Europe as much as possible. So to start with methodology and tools like background, why are these needed actually at the time being? Well, it is required by EU directive, by EU BSS. When we talk about Europe, we all know that inventory of norm is as a requirement, given as a requirement in each country. But we also wanted to get an overview, as I said, of norm exposure situations, different ones in the whole Europe, and then to try to characterize the most common norm exposure situations, scenarios, and to see what kind of other hazards and what kind of industrial but also environmental parameters can affect these naturally occurring radionuclides and can produce some possibly higher or doses that effective doses that can be of concern. So with this, we really want to meet existing and coming activities of mining, extraction, dismantling, whatever activities in different European countries. For example, just as an example, what needs dismantling? Are we entering the decade of offshore decommissioning? It was in the report, in your European report of oil and gas industry, it was said that about 3,000 offshore installation will be dismantled or decommissioning before 2030. This represented 33% of fixed and 43% of floating platforms. Then we had the initiative of coal phase out in European Union for all coal power plants by 2031, for coal mines 2015. Of course, these dates are not fixed dates because of other circumstances. It can be a bit postponed, but anyway, this is something that waits. And then add to this different phosphate processing facilities, titanium dioxide plants, many more norm involving industries that maybe need cleaning, complete decommissioning and dismantling or whatever. So we will have, and we already have in many countries, many norm challenges, because norm can be present in large quantities, and then real data on naturally occurring radionuclides are needed to better understand this line from transport of radionuclides, then to understand the process of their accumulation, but then also transport, how to do the parameterization, and then to do models to be able to predict how they will behave and what would be the magnitude, potentially magnitude of their from these radionuclides. So how to make a norm inventory in a country? We all know that historically a focus really was on artificial radionuclides. Well, that was something that's not strange, but naturally occurring ones came into our focus only recently. But when I say recently, it's I don't think on years, I think on decades. From 1990s, very high interest for norm. Before that, some case studies on oil and gas or other norm involving activities. But from 1990s, interest both from regulators, but also from researchers started to raising. And then in the latest EU BSS, but before that also in or in the same time almost, IAEA provided lists like giving us the norm involving industries. These are indicative lists, so it doesn't mean that lists contain all of norm involving activities, but the main ones are there. But as you could see in the paper that I will mention and present today, the additional activities are identified in our work and experts exchange from different countries. But when we started work in this task and in this working package and started discussion on norm involving industries and how to map and how to get the information on this, we realized that still there are countries that need a clear developed methodology and then tools to make a norm inventory. And this is for Europe. And Europe is, we can say, on really high level when we talk about norm inventory. If we just look at a wider picture worldwide, then this is even more, because there are many countries that need developed methodologies step by step how to do norm inventory. Then we said, okay, let's do a radio norm activity on this. This will help countries in Europe. This will give us updated information on status in Europe, but also we can help countries worldwide in different continents. So this is about methodology to start for. We developed methodology for norm sites identification, and this was the work that would allow to start from the scratch. And this is chronologically by 4 tiers. That allowed you to start from the analysis of the presence of natural mineral resources. Usually there are kind of databases or something like that in every countries, or you can find mineral resources databases on European level. And then there is the need to analyze the presence of naturally occurring radionuclides in these natural mineral resources. This would be the first step. Then in each country, the next step, next year, would be identification of ongoing and any former mining industries, because also active and inactive can be of relevance. Everything is shown on the bottom of the slide in the schematic form. So when we have these mining industries and we know what is mined in our countries, what kind of mineral resources we maybe import and what we have in our countries, we can have an overview about mineral resources and a norm in these mineral resources. Then next step is to identify ongoing and former mineral and fossil fuel processing industries. And this is maybe the biggest step because there are many different mineral processing industries. Some of them will use imported resources, raw materials. Some of them will use the own national. So we should be able to identify and to map all this in this process of making inventory. And the final step here would be analysis of commodities and product life cycle, including their application and of course final disposal, because in all these steps, from step 2, let's say tier 2 till tier 4, we will find residues, norm waste that should have a final disposal or final use. And that's very important point to consider and to get the right information on. If you start from this, you can be sure that you will not miss anything. I don't say it's not time consuming. Of course, it's time consuming. It's something that needs resources, both financial resources, but also human resources, good knowledge, but it is possible to do. Especially because we developed a matrix of norm identification tiers, when you can see on the left side material, on the upper part activity. And then we can start, as I said, from natural raw materials and go directly in line through mining and mineral processing to consumer goods use. But we can go also differently through this matrix figure. It means that as many countries in Europe are not at zero level when we talk about norm industry, they are at some level of norm inventory. They know about many or some norm involving activities. So they can start, for example, from tier 3, from mine output, or they can start from a different industrial products application or mineral processing. So what we wanted to show with this practical approach, with this matrix, is that you can use the developed methodology in two ways. You can go from tiers by tiers, from the scratch, following 1, 2, 3, 4 line, but you can also go from the point where you have information, and then it would be shorter or easier or whatever, depending on countries' prevailing conditions and depending on the knowledge that already exists in every country. So everything and much more about this is given in the paper given here, a methodology for the systematic identification of norm, that was published last year. My colleague Boguslav Michalik led this work, but we all contributed. Here are some advantages and disadvantages, or some challenges. So as I said, it can be used from scratch. It will give an exhaustive overview. There is a possibilities to start at different tiers, and also you can go from the simultaneous gathering of relevant data and information. So if more people work, and you can go from one step and another step, so you can then compare what you have. So these are all very positive sides of the methodology. But this is time consuming. I'll also mention this. There are many countries reported, especially in norm survey that I will present it, that they have a knowledge gap or resource issues, because there is a need for people and money to do this inventory. And also what started to be also an issue is communication issue with different stakeholders, with the public that really wants to know, okay, norm, how will this affect me? I live in the vicinity of some norm involving industries. I live in the vicinity of some water body where liquid effluents of norm are discharged, how this will affect my everyday's life. That's something that is normal, but we need to find a way as experts to communicate that there are people that know this much better than me, and probably you will talk more about these things. And then in the methodology paper, we just touched, we didn't develop, we didn't work too much on this, but the idea was to use life cycle analysis to get further development, idea for further development, because you can also find norm using this life cycle analysis to assess radiation exposure at all stages of product life. From mineral processing, you can find, here is a simplified life cycle analysis of abrasives applied in bearings manufacturing. So you go exactly these tiers that I mentioned, from mineral mining and processing, then to preparation of this abrasive, trade, transport and storage, application, and then waste, where and what kind of treatment and what kind of disposal these materials will go, from the start of the use of some product till the end of this product. This is very simplified, of course. This is this needs a really long time work to develop, but this is just the idea for further activities if it would be possible. Then I will go on tools to characterize norm sites, and when we finally have them identified. The ideas for developing these tools was to facilitate comprehensive, but to get the information in a systematized and harmonized way, both qualitative and quantitative data. Then this data would be used to support regulatory issues for initial or periodical revision of norm inventory. This is also requirement both for initial and periodical revision in EU BSS, to obtain an updated European overview, and also to provide support to teaching or practices for a process of norm identification and characterization. And I mentioned also supporting other countries that are at different levels. In this register or questionnaires or surveys, we used all terms, tools, but here is norm registers. We covered for when you, under point 1, when you have norm site identified, we will with tools, we will get collect information on production part. It means information on raw material, main products, residues, but also on the right part of this figure, on the release. What can happen in these norm involving activities if we have norm released to the air, to the water and soil, sorry. So environmental contamination assessment. And this is really comprehensive registers, because we targeted international researchers, we targeted regulators that conduct norm inventories, industry operators that may use register for an initial screening in this graded approach that should be developed by requirements in EU BSS, or if they want to do a systematic radiological characterization and impact assessment at their site. For example, if public attention is really big, and also academic and international experts doing training courses. Here I put just a flyer from the last one, a radio norm course on norm, organized by mining industries, by GIG, mining industry in Poland. Bogusław Mikalik was the main one organizing this, and we both used methodology and these tools to present and to explain to people who started work with norm, but also people who already work with norm, but need some small details how to do that and what would be the easiest way or way for getting more comprehensive data, something like that. This is the list of developed norm registers. There are 15 from high background natural radiation areas: oil and gas, geothermal energy production, phosphate fertilizer, zircon industry, cement production, titanium dioxide, primary iron. So I will not read all of this. And then a general one, other norm involving industry that can be used if you in your country have additional identified norm involving activity, and then you want to provide information on that. So key objective was to get an efficient and user-friendly registers for most relevant norm exposure situations, and these registers covered for about 50% of not for 50%, but covered for industries that are still present in more than 50% of the investigated European countries. This is just a snapshot from the register, but as I will had to speed up, I will just say that we have parts on descriptive qualitative data information, quantitative data. We have some predefined information. All parts are color coded. There are log sheets, open and closed questions. So if you are interested, you will go to this paper published also last year in Environment Internationals, where these topics like legislative aspects of norm management and regulatory approaches, occurrence of norm in different materials and in different industries and existing exposure situations, activity concentration, so it means the quantitative data, other hazards other than radioactivity hazards, mobility, accumulation and mobility, monitoring program, and dose assessments, and finally destination and treatment. All these topics are covered by norm registers or these developed tools. And then the third part, and will be finished. I hope I'm not too much over the time. So the third part that we also wanted to, and we conducted to get more information, was developing and conducting norm electronic survey that was published on Radon Norm website, but also circulated in the Europe through different channels. This was a joint work of task 25, 28, and 55. And the main idea was to gather information from regulators, operators, and stakeholders across Europe to get an overview of norm sites, to update approaches for modeling of long-term prediction of norm transfer, and to get also information on radiation risk mitigation measures that are applied in norm involving industries and remediation of legacy sites in Europe. So what we get, the main information is available in here in this paper. I assume the presentations will be available after, so you can, but these papers already are on Radon Norm site, so you can check there if you are interested to get more. I mentioned targeted groups. These are the basic information. You can see the map because we wanted basically to get mostly information for countries that are not included in Radon Norm, especially not included in these tasks 25, 28, and 55. But some countries that also are included, they reply to survey, while some countries like, for example, France, they didn't reply to survey, but they sent information in very detailed way by Excel tools. So being gray in this figure doesn't mean that you are not, you will not be included, your country will not be included in detailed analysis provided in the deliverable. So overall response rate was 19 countries, about 34%. We realized that norm operators were interested, but mostly regulators replies. There are reasons for that, but I will not go into such details now. But what was added value is that we got information and data from Lithuania, Estonia, Croatia, Bulgaria, Slovakia, all these countries that are not included directly in the radon norm. And this is especially added value to collected information and data. Not only here I put task 2.5 because I'm obsessed with my task, but it's also for task, I'm sorry, for task 2.8 and task 5.5 especially. And this is the last slide, overview of existing exposure based on norm survey. We can say that countries are at quite different levels regarding knowledge on their norm involving exposure situations. Challenges that are identified by responders of this survey regarding norm industry regulatory control are human resources to conduct this inventory, as I mentioned. Then inventories in many countries are done to some degree regionally, but they are not always compiled at national level. It also depends from country to country what kind of organization country has. Then norm control is, although norm is first mentioned in EU in 1996, maybe not first, but more explicitly, but then in 2014 very explicitly through requirements. But still we can say that norm control, or people, not we, but people responding to this survey said that norm control is still a new issue, and introducing legal solutions, that this part is done, but this needs and requires interpretation and establishing procedures and developing good practices. That's why exchange on international level is really important. Then we identify a challenge regarding approach to large volumes of waste containing norm. Usually this waste doesn't has very high norm concentrations, but we have a large volumes, and that's a problem for disposal sites, capacity of disposal sites, then also transport across borders, trans-boundary movements of the waste. If the legislation is not harmonized, because not all countries have always the same levels, although the most of them adopted EU BSS values. Then communication of radiation protection requirements to norm and communication to understanding stakeholders in both direction, monitoring programs, approaches to dose assessment or modeling for humans and biota that can be used daily in the regulatory practice or in industry's practice. It's very important to have models that can be easily, or maybe saying models and easily is not very compatible, but at least to be able to use models in a way that both industry operators understand what they do when they model, and regulators also to understand in an easier way what are the results of the modeling, and should we have regulation of this, or this is just putting non-necessary burden on industry. So to finalize, there exists a good understanding of legislative requirements, but also different graded approaches for control are developed in different countries, depending on previous knowledge, on previous developed infrastructure, on current state, on predictions, for example, for disposal sites in future, or predictions for developing new or dismantling old industries. So all these things will in a way affect how we will develop the regulatory control. Here is, but I will skip this slide. You can see in the paper norm survey, the norm industries overview in European countries. Most of the raw material do not contain elevated norm, but due to, for example, temperature, high temperature and mass reduction, then we can have accumulation of naturally occurring radionuclides in scale, sludge, filter material. Okay, I'm finishing. So these you can see radium-226, 228, lead, polonium. These are the main radionuclides. Radium protection measures are in place together with occupational health and safety standards, and exposure dose considerations for workers, publics are in place in regulatory practice in many countries, but consideration of non-human biota still, we can see that assessments still have an anthropocentric approach, and not many countries do the assessment of only human biota. Then there were 2 slides on liquid norm and norm residues and waste, but I know that Boguslav later will present also on this, so I can just skip and say that just liquid norm was identified as a very important topic that needs further work, because there is no clear guidance, clear requirements in EU BSS how to do, what to do with this. And also norm residues and waste. In some countries, norm waste is never radioactive waste. In some countries, depending on concentration, it's always radioactive waste. Where to dispose, what kind of requirements to put on disposal sites. These are very complex topics, but I assume Boguslav will talk a bit more on this. So I will just finish with saying thanks to all Task 2.5 colleagues for a great joint work that resulted already in 3 papers published, but we are working to get final deliverable and maybe some more publications. And thank you all today for your attention. So I will stop sharing now.
Thank you, Yelena. And we have a very short time for one question from the audience in the room, if there is any, or from the online colleagues. I don't see the online here, not, so we can.
Okay, I hope that I stop sharing or.
Yeah.
Please,
Yes.
very, very short, because we are
Yes.
slightly on late.
Can I ask a question? Sorry.
Yeah,
So-
fast.
Thank you, Helena, for your very comprehensive presentation. I have just sorry, a comment for you. What do you think about, you said in the beginning that we are expecting a lot of dismantling from oil industry now for the next years, and in the last slides you said about the capacity of disposal is an issue for many countries. So how you see these 2 issues? A lot of oil industry are dismantling, and a lot of norm waste, and the capacity for the countries to deal with this waste.
Yeah, that's the, thank you for this question. This is really nice question, because we already discussed, there is a case in all these countries that have oil and gas industries. In Norway, we have a special disposal sites that receive only waste from oil and gas. Luckily, we scale and sludge usually has high concentration of norm, but it's not so large quantities of waste from this type of industry. But yes, in some countries there are ongoing strategies for waste streams and how disposal, what would be the level of disposal site needed for up till 2100 year, and to be able to receive all the waste from oil and gas, but also from other, for example, mining or construction industries or different types that will. So these two things, yes, are somehow connected and difficult to answer at the moment, but I suppose this will be a question for every country and a national question. Yeah.
Elena, I'm really sorry, but I have to stop the discussion and
Yes. Yeah.
to the next speaker.